Good morning. Welcome to lecture 17 of thermodynamics of materials. We will discuss today irreversible adiabatic process. So, this is the second case, second one. Adiabatic continued, adiabatic process. Yes, continued. We have completed reversible adiabatic. Okay. Irreversible adiabatic. So, first case is against expansion against P external is P2. P2 the final pressure. The final pressure. Now, let me sketch this. Thank you. Okay, follow this. Note reversible adiabatic, the reversible adiabatic expansion discussed last class, in the last class. So for comparison, I am sketching the reversible start volume. First draw the reversible. Just what we got. This is the reversible diagram. 1, A, 2. Write somewhere. Right? Reversible adiabatic. Write somewhere. Right here. Right here. Okay. 1A 2 reversible. Reversible adiabatic 1A2. Give the states P1, V1, T1. Note that all three parameters change. P2, V2, T2. This is reversible adiabatic. 1A2. Then today we actually start what? Irreversible adiabatic. So how will you carry out this? How will you carry out this process? Okay, recall this compare reversible adiabatic and irreversible adiabatic quickly. This is a sketch you know very well. This is the reversible adiabatic. Just for comparison, I am showing once more P1, starting P1, then P1 minus dP, P1 minus 2 dP to P2. This is the reversible. This is the reversible. But the irreversible, in contrast, you again start with P1, but abruptly change to P2. Okay, so write state 1 here. State 1 is P1, V1, T1. What is the reversible was? P2, V2, T2. is reversible. Is irreversible. First one against P external is P2. So we try this. So let us drop the line. As you know, in case of isothermal, you just drop this line, and then you see final pressure is P2. Okay, you may note here P2. This is P2 pressure. This is P1. This is V1. V1. This is V2. This is V2. Okay. Now you see, interesting, whether the final state will be here. Just give a logic here. The logic is this. You see. So in case of adiabatic, okay, dq is du plus dw. First law. First law. First law. For adiabatic, zero is du plus dw, or dw is minus du. Now you follow one thing. So you follow this, or w is minus delta u, finite change. Okay, one thing you follow, I say that final state will not be here. Unlike isothermal final state is here. Initial, reversible and irreversible also, initial and final same. Intermediate states are non-equilibrium in case of irreversible, but this is a very exceptional process, adiabatic. So now we will verify whether this will be here. Let us see what is the final state. You give a logic here. I am giving you. Now please tell me what is this? W reversible is greater than W irreversible. Adiabatic I am discussing. Adiabatic. First of all, accept this or not? Why we accept? Because I said that for isothermal and adiabatic, reversible work is greater than irreversible, but this principle you can see here. This is the area under the curve is under 1A2. Achha, give a name to this. Give a name to this. 1 irreversible adiabatic 1B2 against achha, keep it there. So what is the area? What is the area? 1A2 and it is 1B2. Which is greater? 1A2 is greater. 1B2 means this much. While 1A2 is actually plus. Okay. So this work is greater. You can see very easily. Say this is 40 joules. Just example, easy say 40 joules against 35 joule. Now what is W reversible? You may note this. So minus delta U reversible is greater than minus delta U irreversible. Here reversible, irreversible, both are adiabatic, remember. I am comparing reversible adiabatic final state, which is 2, and irreversible final state, whether it will be 2 or different. Starting post is same, starting state is same, 1. What is the diagram here? Start same, but whether it will be here or maybe somewhere else. So you follow this logic, or that means it is actually or delta U reversible is less than delta U irreversible. This you have to accept. What is this? What is this? Tell me. Reversible minus 40 must be less than minus 30 joule. Delta U is what? For internal energy is a function of temperature, CB dt. So delta T reversible less than delta T irreversible. Again you write, what is delta T reversible? Follow there, T2 minus T1 must be less than, this case, I'm saying that this is the final difference. If it is different state, we do not know, we'll check. Let us consider this T2 prime. We'll see if it's T2 prime same as T2, then we'll be satisfied. But let us call it, its final state is T2 prime minus initial is of course the initial. Or what you get from this? Or T2 is, what is this? Oh, right here. Here, you get star, right here, star. So, T2, you do one thing, minus T1 cancel. Or T2 reversible is less, T2, that is for reversible final state, is less than T2 prime, which is prime I have given. Considering it will be different, or maybe we'll check whether it is different. We clearly see this is different. So which is greater? T2 prime is, final temperature is not T2, is greater. But final pressure is same, because we have fixed this. Final pressure is same, P2. Final pressure is same. Against the final pressure is final pressure. So what will happen? Temperature is greater. What does it mean? Final pressure same. I will compare with this final state and this reversible final state and irreversible final state. Final pressure same. Final temperature established that irreversible final temperature is greater than pressure same. Temperature greater irreversible. That means volume will be similarly. This means or V2 reversible will be less than V2 prime irreversible. Write in bracket constant pressure. Same pressure means same pressure. Same final pressure. In each case. So you have no doubt. That means will it stop here? Interesting. Will it stop here? This is the first time we are actually facing something where the final states are different. Reversible and irreversible. So this will not stop here. What is the volume? In this case, volume will be greater. So it will be greater in a way so that this is the 2. I am giving 2 prime. So give this as 2. This is 2 prime. The final state of the irreversible process. Irreversible means 2 prime. So what is the irreversible? I am very sorry. You should write here 2. It is extended to. It's further. Okay. 2 prime. This is the final state. What is the final state? You write here. Okay, right now nicely write here, so that there is no confusion. What is this? Right here. It is what is the second this state? P2 reversible. P2, V2, T2. You have no doubt. What is this? Tell me. This is P2 irreversible final state. V2 prime, T2 prime. That's it. Whenever you come across adiabatic, you will be on your guard. Very deceitful process. Difficult, not easy. For this is the complications that started. So what we say about this here? This part is okay. This is now quickly remove this. Okay. Shall I repeat this part? Work done. Sorry, I have removed this. Work done. Reversible greater than irreversible means work is nothing but minus delta U. So likewise, minus delta U is greater than. So delta U will be less than. For example, if it was 40, it is minus 40, less than minus 30. And since delta internal energy is a function of temperature for ideal gas. Note here, internal energy is a function of temperature alone for ideal gas. Note this. Moreover, you know delta U is NCBDT, etc. So you get this delta T. you clearly see, okay, this is initial thing, initial state is same. So then this gives you this important observation. If this is valid, then this is also valid. So that means this is not the final state. Greater volume. That means here what you see here, if I may draw this, you have given this pressure, P2 final, then this will get past this point, overshoot this point to perhaps the 2 prime or irreversible. Happy? Okay, this is the irreversible, this is the reversible, this is the reversible final, this is the irreversible final. If you can write, I've written number of places, no problem, absolutely no problem. Now, how to now remove all these things? It's all over quickly. So this is actually quality. With an example, you have established this. But if you want to, this always happens. Okay, quickly. So how to get this value? So how to find? Next question. How to find? Sir, B2 prime, T2 prime. Might say where, sir? Sir, agreed, sir. This will be getter. But here, where, sir? Any relation, sir? So that we can find. These values are known. These are known. You know very well is starting known. And these are also known. Okay? This P2 you applied actually. What is the final pressure you like as well. These are all knowns. Reversible all knowns. Suppose you know P1, V1, and if you know P2, V2 you can know. Tell me this question. How to get V2? Reversible. Get back to reversible. You start with certain initial pressure, volume temperature. Oh, this diagram is wrong. Careful, always careful. If you show this, then very nice. Okay, very nice, insulated. Adiabatic insulation. Drawing. So quickly. Tell me. I'll be happy if you have answered. If you will answer this. Answer this. So you start with T1, this is up to, okay? Start any temperature gas. So 2 atmosphere, 300 liter, 500 Kelvin. No, I'm very sorry. That must satisfy actually the number of moles. It depends how many moles. PB is N. PB1, P1, T1 is must be nRT. P1, V1 is N. Say 3 moles you have started. 3 or T1. That is the relation. Then you choose final pressure P2. Reversible, only reversible. P2. Then V2, you know. V2, T2, can you choose? P2 you choose. Say, what is the pressure you choose? Suppose it was initially hot pressure. Say, 3 atmosphere. Also 2 atmosphere. Now you choose P2 to be, say, 1 atmosphere. So you know P2 is 1. V2 also you choose. It also 3 liter here. Sorry, 5 liters here, okay? PB2, this path has a specific equation. PB to the power gamma is constant, okay? So this may I may write here, PB to the power gamma is constant. You know gamma is Cp by Cv. So yeah, everything. So once B2 is known, T2 is also known. You know, very good. Now take up the problem. Real problem is this, about the irreversible. You know all these things. So you see how to get, question is given, how to find V2. This is the trick. You see, what is the irreversible, okay? Irreversible. You write again, Q is delta U plus W first law, 0. Delta U is what? I am writing N irreversible. What is the, give the name, 1B, 2 prime. You understand everything, I have given the name. Delta U would be, what shall I write? N mole Cb, T2 minus T1, but T2 is actually T2 prime, sir. We want to find T2 prime. You cannot avoid T2 prime. NCB T2 prime minus T1. Here to here. 1 to 2. 1 to 2. 1 to 2. 2 means 2 prime here. So good. What is the W, sir? W is what? I will be very happy if you can answer. Then I will be very happy. Tell me. The way see, it is given here. It is given here. Irreversible process, P external dV, P external integration, P external is a fixed again, P2. So P2 times volume change, PdV integration, okay? PdV integration, P external dV. P external is P2, 1 to 2. You can do this, huh? This will go, this is a constant, will come down, out, okay? So P2, you can see also from here. What is this? Area under this curve. What is this? Hello, P2 times this change, V2 prime minus V1. Mathematically, graphically, so what is this? P2 is right here. P2, V2 means V2 prime minus V1. Write that out quickly. This is very important. So now see, happy. What is the B2 prime? B2 prime is right here. Again write, or what is the B2 prime? Keep on writing. Okay. Keep on writing. What you write? Right, this side. Okay, sorry. 1B. Don't remove this star. Yeah, star. Take up here, or take up here, or write clearly. NCV T2 prime minus T1 is minus P2. What is the B2 prime? B2 prime? Tell me, B2 prime. Sir, I know, sir. Unknown, but T2 prime unknown. So link up them. Link up these two unknown, make it one unknown. One unknown. What is this? So what shall I substitute here? B2 prime in terms of T2 prime? B2 prime in terms of T2 prime? N R T2 prime is here. It is state, equilibrium state. This is equilibrium state. P2 V2 prime is NR T2 prime. P2 V2 prime is NR T2 prime. Okay? So T2 V2, where is your T2 prime is? P2, so on. P2 is NR T2 prime, right. T2 prime, V2 prime is NR T2 prime by P2. P2 is okay though. Is minus P2, V2 prime, V2 is NR T2 prime by V2 prime minus V1. Okay, minus V1. Take a look. P2 V2 prime. V2 prime is P2 V2 prime, right here. Your difficulty right here. P2 V2 prime and equilibrium state. P2 prime is an equilibrium state. Non-equilibrium, final equilibrium. P2 V2 prime is NR T2 prime. As much as here. For P2 V2 is NR T2. As much is there. P1 D1 is NR T1. Okay, so you know all these things. So B2 prime is very good indeed. P2. Yeah. So you get this, or what you are getting, or NCB. You substitute this NCB T2 prime minus T is P2 NR T2 minus V. Okay, P2. So here you know. So what are known? NCB T1 P2 V1 known, all known. You know how many moles you have started with? Okay, these are all known. What remains? It is one equation involving T2 prime. This gives you known, found out. What is the P2 prime? You already know what is the P2 prime? NR T2 prime by P2. NR T2 prime. Oh, you have not checking. Hey, always alert me. Always. What is this nonsense? T2 prime is T2. It is T square. Check this. No, you please alert me or you will correct me. NR T2 prime. T2 prime is T square. Okay. So this is also found out. This is how you will find out this data. Okay. Very good. So all set. This is over. I will remove this. I move on to the next one. So remove this part as much as possible. Remove. First law. Remove. Start. Continued. Start. Take the table. Now complete the table. Now complete the table that we are discussing all the time. What is tell me what are this? dq, quickly. Tell me dw, tell me du, tell me dh. Quickly. What is the dq? Easiest, attack the easiest. du is what? What is the next easiest? So remember it is irreversible. It is irreversible. So what is this? P external dV, that is P2 dV. Happy? P external against P2 pressure. Okay. I am talking of the irreversible first case. Second case I will take up later. du is what? Du is okay. The number of us. You are right. You are right. Du is first. You are right. I should suggest NCBDT, sir. No one can stop. Why it is valid? NCBDT why valid? It is not a constant following. It is adiabatic process. Prepare. All should be on your guard. Any lapse, okay, any slackness will ruin you. Simply ruin you. That's don't worry. NCBDT. Hey, no talking here. NCBDT. DH is always true, irrespective of for ideal gas. You write constant volume for non-ideal systems like real gas, like real gas and any other system, liquid, solid, iron. Careful and very careful. First you will be careful, then what you will be? Very careful. Remember this. So I ask this question. I know you will actually be at fault. That's why I am asking. I know you see you are actually very unmindful, casual. No casuality here. See what is this? By the way, in this CPDT likewise for since ideal gas. Okay, yeah, or right here for ideal gas. du is NCBDT always. dH is NCBDT. Once more I am writing for you. Irrespective of path. Irrespective of path means constant volume or constant pressure. Remember this. So okay. You understand this. Very good. So these are all over. Remove all this now. These are clumsy. This part is answered. Thank you very much. Remove the keep retain these two figures and that top. Okay, quickly. So DH. Now what I will do? I will have to remove this. You have even noted this. I may remove this now because this will be convenient if I place alongside. What I will place alongside? What shall I place alongside? The finite changes, integrated form. So Q is what? What is W, sir? Oh, dW is NCBDT. You right. You said correctly. What is this also? Is tell me what is also minus del W. Means this will be there. Okay. W, then delta U, then delta H. Quickly, please. As many as possible. Q is easiest. Q is 0. W is what? The integration of this. Do this integration. P2 dV once more. V1 to 1 to 2 prime. Oh, reversible all over to reversible all over. Okay, very good. Those reversible all over. Okay, very good. Complete. Is what? Tell me. Since this is this part. This is not a constant pressure process. Remember, not constant pressure process, but this segment I am considering is the constant pressure. So don't mix up that it is this is a variable pressure system. P1, P2. So P2 times V2 prime minus V1. Delta U is what? Tell me, integration. Tell me, P2 prime minus T1. Independently, then you get the link up NCP T2 prime minus T1. You can write. And delta U is also minus W. You can write. You write number of ways. W is minus delta U or this, okay? Okay. This is over. Next is interesting case. So I am actually now do one thing, in a different way I am carrying out this process. Achha, first of all, I tell you my plan. My plan today, I'll consider another irreversible. That is the maximum degree of irreversibility. You know, that is very popular. Free expansion. You know, you remember this? Free expansion is what? Against zero pressure. I will set zero, but the zero will. I'll do that later. Later. So this is first. Second, I'll come. Before this, I'll take up another thing. Right. So please remove this. Please remove. I want to have some room. So next is you consider alongside, or you consider I'm removing this. Removing this. Removing this. Again, I'll draw fresh. Okay. I will now consider. Consider this. Expand now. Reconsider. Now consider once more. Once more. Expansion like this. Expansion against this same. Expansion against P external is P2, but we are arresting the final volume as V2. So it has exceeded. Of course, no, we will not. You know, we have that tricks. We have that mechanism. What is the mechanism? Provide arrestor. Means don't let it get past the final volume as the adiabatic. We'll force that. Impose that. So, but now consider once more expansion and reaction, but okay, forcing the final volume, okay, final volume the same as the reversible final volume, forcing the irreversible final volume, reversible final volume, namely what is that? Tell me. V2, no V2 prime. That means that is no V2 prime this time. So what will happen? I will resketch this part. Okay. So, how will I show you number of ways? This is a sketch. Quickly, and very quickly. State 1, you have no doubt. This is the insulation system. Okay, insulation. Quickly, 1. This is 1. Now next, you follow this, right? P1 is the pressure. What is the state? Initial state is initial state, no doubt, no conflict. Okay. Next, what we are doing? Against P2. Achha, what is the reversible counterpart? Tell me. Reversible. This is again right here. P2 for reference. Don't worry. See the way I am writing P2 means this is reversible, right? This is for reversible final state. What I am doing? Follow. That I am now changing this to P2. External pressure is P2. Then what is the final volume? You know? What is the final volume? You knew. It should be past V2. This, but we will not allow this time. We will allow V2. So what will happen? So we will provide an arrestor here. Provide an arrestor. Red stocks are out. Arrestor. Right? Arrestor means volume arrestor. That will fix the volume V2. That is possible. So one way we have achieved V2. Okay, this time is what? What is this V2? Now tell me again tell me. So you go this way, you go that. I'm sketching this for you. I'm sketching here. Follow me. I'm taking trouble because I don't want to make it clumsy. Retain that. Again, repeat. Again, always draw the reversible adiabatic for reference. Now tell me. Follow. Irreversible. Arrow. Give always arrow. Maybe double arrow to distinguish. Here also similar double arrow to distinguish the irreversible. Follow me. Quickly. Again B. So what will happen? The volume will be contained in V2. But do you again think that the work done is same? Final temperature will be same. final temperature. Work the same logic, work done is still less. Yeah, below this curve, less. So temperature drop is excess, final temperature is greater. I have enforced final volume V2. V2 is same for same V2. For same V2, final temperature is greater than the final reversible. Irreversible final temperature is greater than the reversible final temperature. What does it mean? What about the pressure? Volume same. What's the pressure? Pressure greater. For the temperature increases, volume increases. Pressure constant. Volume fixed mechanically. Okay, by an arrestor device, then it will pressure. So this is your 2, in this case 2 prime. Okay, so tell me what is the status? Tell me, can you give me this one? What is, okay, give a name, 1B C 1B, what name I gave there? 1B2. This is 2 prime, na? So you give it 2 double prime, don't mind, So what is the name of this path? Path is this irreversible path shown by good 1B2 double prime. Follow. So what is the final state? I will be happy if you can tell. Let us see. User will tell us what is the final state. See, tell something. Okay, again you write P1 T1 at the top, no problem, satisfying. P2, this is a reversible final, this is an irreversible final. In this manner, okay? So in this manner, so it cannot get past. So what will happen? Tell me.
P2 double dash.
Good boy. P2 double dash. B2 is unchanged. T2 prime. T2 double dash. Okay. So note T2. Note here again. T2 double dash is greater than T2. Irreversible final. Reversible final. Irreversible final temperature. This is reversible final temperature. Happy to? Very good. Quickly. And also, since T2 this, okay, so the volume same, temperature greater, means, hey, what are you doing here? Stop. What are you doing? So drawing you are doing here. Get out from this course. Get out. Stupid things. Come late and then you are, get out. Don't disturb me, okay? And you are doing the same thing? Okay, get out. So this is, okay, so this is, what is this? P2. So I missed the Q actually, So pressure, P2 prime. P2 prime will be what? P2 prime will be T2 prime. This is, compare these two, okay? Compare these two. Where I am drawing this, okay, this is. Again, like this is what? P2, V2, T2. So T2 prime greater, so P2 prime greater. So P2 prime will be greater. So also right here, this leads to P2 prime greater than P2. You have difficulty? No problem. So our external pressure and internal pressure defined, no problem, because this is actually, and this is a system where no free interaction between system and surrounding. Arrestor are free, not free. These two is not external and this internal is not free. Arrestor stands in the way. Like I said, okay, this is possible. But system within is equilibrium. This is a very little equilibrium state. This is the equilibrium state. This is the equilibrium state. As much as this. This I said, this is possible also, because free interaction not available, you cannot expect. Since free interaction between system and surrounding not available, you cannot expect T surrounding is T, okay, like say, but here particularly, P surrounding is P system, which is P surrounding is what? Sir, P2, and P system is P2 double prime. Okay, and P2 double prime has been greater, inside is greater, obviously it will be greater, because it has mounted there. Since it cannot expand, so pressure has mounted. Happy? Let us progress with this. Now I actually help you, okay, what I should tell you. Keep that, I'll have some discussion. Second is, what will discuss? So free. Actually now, tell me, 2 prime. Actually follow this. I'm actually consider, I'm actually not, Okay, okay, this one disturbing that figure. Here I am showing not P2. P2 is one of the choices, the commonest maybe, P final pressure. I see there are two possibilities, but there are other reversible processes, and I said infinite number of irreversible. I am further changing. What is the final pressure I am considering? You consider? Yeah, please follow. I am showing P3. Why P2? P3, why P3 is even less than P2. I have arrestor. I have an arrestor, so I will fix the volume, B2. Maybe less, let it be. Eventually, system pressure and surrounding pressure will be different. So, yeah, I already accepted that. So, why not? So, degree of irreversibility, they call it. Get at the driving force. Driving force is even greater now. Okay. So, what was the driving force here? What was the driving force here? P1, P2, no, this P2 minus P1 here, what is the driving force? Okay. This here, P2 minus P1, it is P3 minus P1. Okay. So, I would say P1 minus P2, P1 minus expansion, pressure have decreased actually. P1 minus P2, P1 minus P driving force. Finite, sir, even more finite. Later, 15 minutes later, 15 minutes. You just roam around, P3 less than P2. Happy? Happy to? So, greater degree of irreversibility. No. Stay away from my view, okay? Stay away from my view. 15 minutes, 900 seconds. Count 900. Okay. So greater degree of irreversibility, you may say. Right here, note this. Greater, you remember degree of irreversibility, I said? Maximum degree of irreversibility. Greater degree of irreversibility. This is too much, actually. Now consider, I don't want to disturb. Greater degree of irreversibility. So can anyone tell me how shall I draw this? I am trying to draw with you. Start. Knock off. P3. Suppose P1 was 3, it was 2, now it is 1. Or 2.5 even. 3, I'm sorry, 3 to 1.5. Even less. So how shall I draw? Less. So this is P2, for your information, this is P1. And this is now P3 somewhere here maybe. So it will drop to, how will drop? First drop. Good, very good. Answer this question. Carry on with me. So this is your P3. Happy, sir? P3. Drop. Then what will happen? Expansion, sir. After drop, sudden drop, then expansion. It will get past. Arrestor is there to maintain the volume. Then what will happen? Go up. Will be here, still above. That is this. Because this time his work is even less. So final temperature is even more. Expand. Okay, expenditure or say consumption of internal energy. Expenditure of internal energy is even less. So final temperature is even greater. Final pressure is even greater. Okay. So this will be where? Tell me. Imagine. So even less work. Less work means there are what's 30, 40. I said na 30, 40 here. Reversible 40, 30. It is even less. 20. So you will place the logic. You will see actually internal energy drop minus is that value. That is minus of this. Okay. So numerically it is even less. So final temperature will be even more. So maybe this. If you don't mind, this is 2 triple prime. Okay. If you may consider this just to show. So here follow again. Repeat. Reversible. Irreversible external pressure P2 goes up here. Give post here. This is a 2 double prime, and even less pressure go still up. Here it was here. It is a variable volume, constant pressure. So volume was free to move. Free to attain. So this was this value. Here opposite, pressure is fixed, so volume is fixed. 50 minutes not, I know what is 50 minutes. So it is past this class now. Let him wait for 50 minutes. Okay, 2 double prime. So this is 2 triple prime. 2 triple prime. Okay, so it's further up. Happy to? Very interesting. You go through this. So what is this state? If you are interested, you can write this. Okay, P2 double prime same way. So temperature will be okay. You comes in, you can do yourself. Next. No, sir, you are doing it. I just P4, P5, P6, P7, P8. I'll be tired. Infinite. Maximum. Sir, keep the maximum there. What is that? Maximum degree of irreversibility means what pressure? What pressure? Yes, yes. What pressure is applied? Maximum degree of irreversibility? Huh? Almost no, exactly zero. Free expansion against vacuum. Use all these things. Free expansion, sir. So last is what? Here again. Again, I'm trying. I'm again trying. Here, this side, comes in, no. So, time, zero, right? Free expansion. Free expansion. Maximum degree of irreversibility. Write this. Free expansion. Write also this. Free expansion. Right here. Maximum degree of irreversibility. Good. Irreversibility. Maximum degree of irreversibility. I'm not free expansion or against, right? Free expansion means, right? Pressure against vacuum. Expansion against vacuum. Against, okay, P1 is 0, free expansion right here. 0 means free expansion. Right here, somewhere. Expansion against vacuum. Write all these things. Expansion against what? Vacuum. What pressure? What pressure that? P external is 0. Vacuum is 0 pressure. Okay? That is P external is, write all these things. I'm trying hard. Okay, so this 0. So can I sketch? So 0 means what is the again? What should be the corresponding volume again? Infinity. Cannot be get past arrestor station. So do this. It's better I should have used different color. Okay. Do this. Where it will be? What is this pressure? 0 is where? Y-axis 0. So hits the x-axis. Then takes a turn. Oh, better use that chalk, which is not available. Use this. Hit, turns. Tell me. Go up. Not this. Oh, Baba, never. Volume is arrested. So I'm checking all the time. Lest you should be unmindful. Okay, up.
With one.
We still want, still above. So this one, 2, 3, 4, 0 pressure. So final pressure, final temperature will be even higher. So now what is the work done? Zero work done. So 0 drop in internal energy. So what is the temperature here? Temperature, no drop in temperature, no drop in internal energy, no work done, no drop in internal energy. So no drop in temperature, that means initial temperature. So means greater than this. Is greater than this. So what is the temperature? Right here. So first of all, pressure is what you have done here. Volume. Okay. Pressure is what? What is this? What is the pressure? Oh, that you have to write. P2. I have to do it. V2 is V2. Temperature is T1. Because there is no drop in temperature. Temperature is gradually greater actually right here. I mean, right somewhere here. I've written here T2 greater than T2 though. You write this, what else I have given? T2 double prime I have shown. And greater than T2, you write here. What is the third? You write here. Note. Here, give this. Note. I give this. T2 double prime greater than T2. Tell me, the second degree of irreversibility is T2 triple prime. T2 triple prime still greater than T2 prime. And what is the last one? This is free expansion. Maximum degree of. What is this value? This is, tell me, T1 itself. Initial temperature, no drop. Now, what does it mean? It will. So these two temperatures are same. Means it must lie on an isothermal curve. So initial final same. It cannot be otherwise. So there must be an isotherm. Because isotherm are rectangular hyperbolas. Okay, go parallel. So this is, if I may draw, though a little bit distorted, little bit incorrect, but this is the isothermal pole. process, okay, reversible though, but hit that point. It hits the this isotherm. What is this isotherm? Tell me. T1 isotherm. T1 isotherm. Okay, that is reversible isothermal will be this. Though this curve is little bit erroneous, but this is the isothermal process. Remember isothermal process? You have seen rectangular hyperbola, but this is slightly distorted. But this is the isotherm. This is the total development. Reversible to various degree of irreversibility. Over quickly some questions will be taken up. Let me finish this first. Quickly. Start listing. Table. Now take up the table. Table for maximum degree of irreversibility. What do you call this? As free expansion. For free expansion. That is right there. Expansion against vacuum. That is expansion against vacuum. Sorry, I'm going too fast. Vacuum, write all these things. And that is tell me maximum, or write in bracket maximum degree of irreversibility. Good, over. This part is almost over. At least some satisfaction that this, okay, table quickly, how you know what is table, you know? dq quickly, du quickly, or dw, du, dh, please quickly, I'm going hurry, don't go slow. dq is what, I know very well, being adiabatic, no way. Any work done, section, area, why no work done graphically? Yes, Amar will tell us why no work done graphically. Graphically, how you show that no work done, sir? This case. I'm discussing which case? I'm discussing maximum. I'm discussing which case? So don't ask. Which case I'm asking? Follow with me. I'm going slow. See, this could have been actually, so completed 10 minutes. Okay. So this means without actually leaving students actually, clueless. That I don't want to do. So which case? This case. This special. See, reversible special. Irreversible commonest. Sir, final pressure. And this is the maximum degree. Actually, I showed the development here. That's why I consider this. This has a question of considering. So this, what is the graphical means area under the curve? What is the area? Marged with the x-axis. 0. No area, sir. So your concept is also against 0 pressure means no. What is lifting? Any pressure system, gas is lifting anyone. 0 pressure, 0 barrier. No work done. So conceptually, graphically, and mathematically, P external degree, HP external. So no way, sir. Du is very good. First law, 0. DH is actually this gives you dt is 0 actually. So DH is NCP dt, all 0. So quickly finish all 0. Very good, sir, situation. So Q is 0. W is 0. Delta U is 0. Delta H is 0. Happy? Over. This part is over. Last question about this. Follow this. Okay. This figure. I'm removing this. All remove this. Remove. One fallacious question. One fallacious. Spelling is fallacious. Okay. Fallacious is okay. Double L. Single. Too much of fallacy. Fallacious question is 1L. Sometimes actually, fallacious question. Quickly. Acha, you follow this argument and answer. Acha, we know. Acha, reversible adiabatic. Please follow. What is the reversible adiabatic? Tell me from that figure. Figure 1A2. Or 1 to 2. 1 to 2 I'm moving. 1 to 2 I am moving. Okay. Reversible adiabatic. What is this? So apply equation. P1 V1 to the power gamma is constant. Reversible adiabatic. P1 V1 to the power gamma is quickly. Happy to? Irreversible adiabatic. I am applying. Which one I am choosing? Tell me. 1 to 2 prime. So what is that one? That figure. That figure. Maybe a double prime here. That figure. Come on in. Come on in. Okay. Is what? What is this? Tell me. Can anyone? What is the initial? What is the final? What is the initial? What is the final? Hey. What is the initial? What is the final here? 1 to 2 prime. What is the initial? 1 to 1b. 1b. 1b 2. 1b. Tell me. What is the initial? What is the final? What is the initial state? What is the final state? His name I forgot. 1 b 2 2 prime. What is the initial state and what is the final state? I will apply Pb to the power gamma. What is the initial state? 1 you said, sir. What you said, sir? This is so difficult a question. 1. What you said? Final is what? What said that finally? 2 you said. What I said? Let us say 2 prime. 2 prime. 2 prime. So 1 to 2 prime basically. You apply again. V1, V1, V2, V2, etc. So I am applying here. Quickly. V1, V1 to the gamma is, tell me, P2, what is the final question? The P2, both are P2, both are P2. P2, B, gamma, compare the two equations quickly. Left hand side same to, left hand side same, follow, repeat, reversible adiabatic. So between 1 and initial and final, state, Pb to the power gamma is constant. State, irreversible adiabatic, state, equilibrium and Pb to the power gamma. So, but I have given, so comparing what you are getting, remove all these things. This is over. So, comparing left hand side same, that means right hand side P2, P2 same. Comparing V2, that's magical. See, I have done V1, V1 to the gamma is okay too. Pb to the power gamma is constant for adiabatic process. Pb to the power gamma, I am applying. After we have achieved everything, all success, where we are actually kind of in a euphoria, very happy state of mind, excited state of mind, then we see suddenly, as if, so Pb to the power gamma if I apply, all many different ways we will try to check or study. So Pb to the power gamma, very good, sir. Pb to the power gamma, very good, sir. But this side same, P2 is same, say P2, P2. But V2 is V2 and question mark. But V2 is not, but V2 is not. Right? Then how will resolve this? So we are getting a, can anyone resolve quickly and very quickly? What the wrong? What do you go wrong? Why it should not apply? Because it is irreversible adiabatic. That rule Pb to the power gamma applies to reversible adiabatic. So if you follow the deduction, you will see dq is deduction. Can you go back to the deduction quickly? Deduction. Pb to the power gamma is constant. Pb to the power gamma is constant. Go back to deduction. See where I am applying reversible. Tell me. First line what I wrote. dq is du plus dw. Deduction. Recall the deduction. dq is Pb to the power gamma is constant deduction. Follow. Where have you used the reversibility? Can anyone tell me where? First part, Pb to the power gamma is constant, there is a proof. You have not attended all classes, okay? Pb to the power gamma, you are also similarly, you two guys, you have maybe. What I have done, okay? Tell me where, this one, see, tell me where. Tell me where I applied. Just start, I am getting you started, then tell me where is the reversibility here. Why? I have written that, but why I applied? So, not why I am looking, I got you there. So where it is? Many different questions may be asked. So answer this question. Your answer paper is there. Your notebook is showing it. I can get you here. See now. You see where it is reversibility. You see looking there. I am helping, hinting you. What is the name of this? What is the topic? Is what? Bas. Then why have you applied the reversible? Oh, if I say reversible adiabatic means it is reversible adiabatic. It can be irreversible adiabatic also. Why is the wrong? Why not it is irreversible adiabatic? Pb to the gamma is constant. Why it is not applicable for irreversible adiabatic? So deduction. Show me. No. Where there? First line, second line, third line, fourth line. See there. Where?
dq is 0.
dq is 0 for adiabatic. Yeah, see, now you see how much you are lagging. How much you are actually now casual. dq is 0 for adiabatic. Universal adiabatic dq is 0. Then, where see there? dq holo. First term is okay, no, your answer is wrong. Then you take if it are irreversible, you could never use PDB. See what a great lesson. So suddenly you say unmindful DW is PDB. It is no meaning. Stop that study. Quit that subject. See, I am helping you. All that first line I have applied. Du is NCBDT, I have applied reversible or irreversible. Du is NCBDT I have written now. See. Is it reversible or irreversible? Then where I applied PDB. If it were irreversible, it can be 0, sir. It can be any value, sir, dW. A moment ago, dW 0. See, that is the magic. That means PBT to the power gamma inscribed in your heart. Ingrained, okay? This. You make it ingrained, okay? So this is what? That PBT to the power gamma. No. He is right. Note. Warning. PB to the power gamma is constant. Applies to the reversible adiabatic. Whole life. Sir, reversible adiabatic. Not to the irreversible adiabatic. Whole life. That means this is wrong. So, wrong application, right? Wrong application. So I'll stop here. Your teacher has come. I'm stopping here. Thank you very much. With this, we have actually concluded today. Okay. Let us call it a day and we'll meet next class.